Hi everyone, in this video I'm going to derive two very useful standard results, which are the integral of e to the x sine x and the integral of e to the x cos x. These two come up a lot in harder integration questions, and once you know how they are obtained, they can save you a huge amount of time later on. So let us start with the integral of e to the x sine x. This is the one where you would need to do full repeated integration by parts, and that's because the original integral will come back again, and then we can use that to rearrange for the answer. So let me start with that one. So the choice I'm going to make for u here will be for sine x, which means u dash would be cos x, and v dash will be e to the x, which is nice because then v will just become e to the x. Okay. Using by parts on this, we've got uv first, so that's e to the x times by sine x. Take away the integral of v u dash, which would be e to the x cos x. So you can see this second integral is very similar to the first one. So I'm actually going to focus on this bit using by parts again. So here we've got u to be cos x this time, giving u dash as minus sine x, and we have v dash is the same and v the same. So if I do this integral here, we get uv, which is e to the x cos x. Take away the integral of vu dash again, so that would be e to the x times by minus sine x. Okay, and if I just simplify this, then I can turn this positive since I've got two negative signs. And what you should notice is you end up with the integral that you started with here. Okay, that's what we started with. So if I put all this together in one go, you'll find that the integral of e to the x sine x gives you, now going back to the start, we have e to the x sine x first. Then we have take away this integral, which is what we did just here. Okay, so if I just plug that result in, like that, then I can simplify a little bit. So this minus sign acting on that, and then you can see the negative sign will act on this, meaning that's now negative. And what you will notice is because we have two of these, I can take this one onto the left side, which means I have two lots of that integral. If you wanted to, you could have just set the integral itself equal to I, for example, and rearrange for I. But I'm just going to do it like this time. And here we've got e to the x in both, so I'm going to factorise that out. Which gives us this, and if that's two lots of the integral, then if we divide both sides by 2, it will give us the result that we was after, which is e to the x over 2 sine x minus cos x plus c. And you should be able to see that that is the top result there. Okay, so I'm going to rub all this out and then we can work on the other integral. Okay, great. Now, the good thing about this second one here is that we won't have to do the whole process again, because what you should notice is when you do by parts, that sine and cos oscillate back to each other. So when we end up doing this first integration by parts, we'll end up with a sine x, and then we can use the result that we have here to do the rest. Okay, you could do it just exactly the same way as what I did the first one in, but it just means that you're doing the same method again. So I'd rather show you this way, since it shows you something different and it's a bit faster. So we've got u as cos x this time. U dash is going to be minus sine x, and v dash is e to the x, v is e to the x. Get rid of that. So this is going to go to e to the x cos x, take away the integral, and then it's vu dash, so that's e to the x times minus sine x. We simplify that a little bit, we get e to the cos x, making this positive now, and we end up with this. And you should notice that this integral is the one that we have there at the top, and so we can just quote this result here. Okay, I'm not going to use the plus c, of course, I'll just do that at the end. So that means that this is e to the x cos x plus, and then we can just quote the result. Like that. And if you were to notice here that you've got e to the x cos x here, and effectively, because of that minus sign, you've got minus e to the x over 2 cos x, this will all go down to e to the x over 2 sine x plus cos x plus c. Okay? And if you're unsure of that, then you can expand it out. So here, if you look at this part, you can see that you've got e to the x cos x, take away that, and that will give you just e to the x over 2 cos x. And if you factor out the e to the x over 2, you end up with this result here. Okay? So I hope that helped. This will help out for the complex integration video that I'll be doing. If this does help anyone, please do like and subscribe. Thank you very much.